Hi, I'm Larissa Dobriansky, and I'm with General Microgrids. As I mentioned earlier, I am a lawyer, and I really wanted to introduce into our dialogue at the ISGW 2018 the need for market reforms. And I'm glad Dr. Verma opened the door for this discussion. I will be building upon, though, what Chris had to say. And, throughout this forum, everybody, has realized how the electricity industry is rapidly changing. And in the United States, the discussions have become extremely intense about the need for market-based solutions. And I'm going to try to share our dialogue and experiences with you. While we have differences in our circumstances, we share a lot in common. Chris mentioned our federalist systems, and of course, we're both facing the sea change based on policy and technology drivers that are leading to the proliferation of distributed and renewable resources. Excuse me for 1 second, I just want to, Raul gave me warning, so I'm watching the clock avidly here. Proliferating distributed and renewable resources that create new points, myriad points of power injection variability at the grid edge. On the other hand, we have obtainable smart technology enablers, information communications and advanced control technologies that can enable visibility, forecasting, and management of variability, provide intelligence, flexibility, and event control, integration and interoperability of resources and systems that can empower small customers as market players and support bidirectional power information and transaction flows. But with increasing volumes, as Chris mentioned, of distributed variable demand-side resources, there will be material impacts on the grid, both at the bulk power system and distribution system levels. We're already witnessing the need in the United States with increasing volumes of these variable resources, the need for resource and system flexibility, fast ramping and cycling, the loss of system inertia, lack of visibility. At the distribution system level, the issues relate to voltage regulation, protection coordination, reverse power flows, reactive power variations, etc. And at this time, at both of these levels, there are inadequate tools to address these types of challenges. So overall, though, there is the need to address these impacts, but these impacts both can have adverse and positive benefits. So there's a need to harness the net benefits of these renewable and DER resources for customers, the grid, and the market. This will require not only reforms of the type that Chris mentioned relating to economic regulation of utilities with respect to grid operations, planning, and architecture, but also market structures, planning, and operations. And I'd like to go over the reasons why we are addressing this so intensely in the United States. Increasing proliferation of smart devices, applications, and systems will increase, with that, the potential for nodes and systems to interact with the grid and each other, creating the need for market mechanisms to coordinate and manage efficiently energy usage and investment decision-making. As these volumes of DER and renewable energy resources increase, market mechanisms can be an efficient tool for system operators to manage grid challenges and opportunities in order to achieve more quickly our policy objectives. And these challenges relate to unpredictable variations in supply, little visibility into and control over distributed resources, continuous innovations in load resources and demand-side management. Market-based solutions could assure the efficient and reliable provision of electricity sources, addressing the need for resource and system flexibility in integrating these resources, the need for new grid services arising from new network uses, leveraging the participation of new market players to deliver value, and providing efficient resource allocation consistent with grid constraints. Moreover, we are examining in the U.S. how market reforms could support transactive energy. This has been defined by the Gridwise Architecture Council as a system of economic and control mechanisms that allows the dynamic balance of supply and demand across the entire electrical infrastructure using value as a key operational parameter. And as NARUC, our Association of Regulated Utility Commissioners, has advised, and this is Chris Villarreal, in fact, this will entail technical architecture and economic dispatch that will be highly reliant upon price signals, technology development on the grid side and customer side, and rules allowing markets to enable a wide array of participants to provide services to the grid and to each other. Here I've just put up a chart to kind of show where we're coming from, where we're going to. Our markets have been structured to support certain kinds of systems, and our traditional markets really are designed to support centralized generation and delivery and to achieve economies of scale. These have linear constraints, and also they focus on the delivery of a homogeneous commodity with active planning and management at the distribution level, and really are designed around fossil fuel-based, inflexible baseload, one-way power flow, inelastic demand, and a wholesale system providing capacity, energy, and ancillary services, but with a limited community of market participants. But they're going to be very new, and their needs are already emerging for digitalizing and sustainable grid, moving towards decentralized, distributed, hierarchical, security exchange, optimal economic dispatch, services and value delivery, and the need for seamless interaction at all scales, utilizing diverse, intermittent, low and zero marginal cost resources, and bringing about multi-directional energy, information, and transactional flows across supply and demand, transmission and distribution and customer nodes, and huge needs for resource and system flexibility, moving from inelastic to elastic demand, load management, peak shaving, moving from passive consumers to active and prosumers, and the need to establish distribution system operator structures and allow in the marketplace the provision of reliability services. And this will bring with it a whole new array of market players to join the existing ones in addressing energy services, transport services, and providing intermediary functions. Now, in the United States, the discussion, the controversy, the activity for more transactive markets has really centered on these 5 areas: pricing, to increase the role and accuracy of pricing, to signal in the short and long-term energy usage and investment decision-making, to expose the value of resources under system constraints and market conditions. Market design, to remove barriers to market participation by new resources and capacity, energy, and ancillary service markets, to develop new, non-discriminatory participation models based on the physical and operational characteristics of new resources and keyed to capabilities needed, and to qualify new market participants such as distributed energy resource aggregators. There's also been a growing movement to facilitate market animation and competitive offerings, while still safeguarding against market abuses, to improve customer knowledge and tools, enhance system-wide efficiency, reliability, and resiliency using market forces, and supporting fuel and resource diversity. And a lot of the activities and discussion have surrounded the development of distribution system operators to perform now transmission system-like functions to manage distribution planning, investments, and operations in order to be able to respond to dynamically changing market conditions and to manage customer-side resources, and also to reduce the need for transmission and generation investments in bulk system flexibility, ramping, and reliability. And very key to all of the discussions and reforms under consideration is the need to make markets more transparent and promote information dissemination, to reduce information asymmetries, increase data access, and develop information sharing protocols to support informed decision making. And here I go in more specifically at what's taking place first wholesale level to anticipate high DER scenarios, and then I'll highlight the retail market reforms. And basically, in terms of pricing schemes, there really are efforts directed at more accurate pricing methods. The type of algorithms that have been used in the past have been too blunt. They've been designed simply to support a legacy structure. but we need more precise, accurate pricing methods to support more cost-reflective prices that can apply to all network users and that adequately reflect time and location-specific conditions, improving upon locational marginal pricing to assure that prices are not discriminatory and are technology neutral. Also refining, in particular, scarcity pricing through more granular locational pricing to expose the value of resources, and allowing demand response to participate in price formation. With respect to market design, as I mentioned, there have been efforts, discussions, and a lot of controversy across our power markets with respect to removing barriers to demand response and DER participation in capacity, energy, and ancillary service markets to put them on an equal footing with supply-side resources. And FERC has opened the door and advanced a great deal of reform and developing new participation models, bidding formats and processes that can reduce transaction costs and recognize the physical and operating characteristics of new resources and, in fact, multi-functions. And also, discussion is underway and proposals to include all resources, including variable resources, in economic dispatch. This is particularly has taken place in Texas, the ERCOT market, and has showed considerable benefits in terms of eliminating manual curtailments of renewable energy, in this case, wind. Those are just some of the types of market design reforms that are going on. But there's also been attention to what types of changes in terms of offerings do you have with changes in the generation resource mix, increasingly renewable, distributed energy resource, and what type of additional ancillary services and products may be necessary, and the kinds of services they can provide. And I provided some illustrations here of different types of services and also products that have been developed in our power markets. And finally, to build the capacity of system operators and developing the tools to better forecast net demand and the value of resource flexibility. On the retail side of things, there is a focus on the efficient use of prices to signal energy usage and investment decisions. And this may ultimately lead to using forward and spot transactions. Forward transactions to manage risk and coordinate investment decisions, and spot transactions to coordinate operating usage decisions. A lot of work is being done to extend locational marginal pricing to capture locational and timing granularity at distribution levels. This we've seen in New York, LMP plus D, and to reflect avoided costs. I'll build upon what Chris was discussing in terms of the developments, and New York has been a leader here, of multi-sided platforms to enable broad market activity that monetizes system and social values and fosters active customer and third-party engagement that is aligned with the wholesale market and the bulk system in terms of the developments at the retail level. And you could take a look later at the type of elements that are envisioned for these multi-sided types of platforms. And all around, there is an interest in increasing competition and offerings while still supporting appropriate monopoly domains for utilities. The types of DER services that can be provided to the distribution grid include distribution capacity, voltage regulation through real and reactive power, reliability, resiliency. And as Chris mentioned, a big focus on the establishment of distribution system operators, perhaps even independent distribution system operators and or distribution system providers that can source DER products and services through competitive processes, taking the form of regulated tariffs, automated real-time, day-ahead markets for day-to-day balancing and optimization of distribution circuits to address system and customer needs. The system operators at the distribution level would provide active management of customer-side resources in response to dynamically changing market conditions. And across the board, steps are being taken to really lay the building blocks for market reform. And they appear in these ways: vision statements and roadmaps that are key to technological capabilities that can realize the fuller value of fusing power and information, developing market incentives to recognize higher value investments, crosswalking organizational silos. And here I think California is a particularly good example of the increased coordination and cooperation between the California Public Utility Commission, its commission, California Energy Commission, and the CAISO. And all are trying to develop stage development of distribution operational markets to address system and customer needs, while aligning the evolution of wholesale and retail markets as we move towards truer costing of resources, reducing market distortions to create more accurate price signals, and differentiation but harmonizing wholesale and retail market reforms. Critical to all of these efforts will be the ability to design demonstrations that are based on scenario analyses. We no longer have to do the regulation and just jump into, the risks. We can design demonstrations to test and evaluate the cost effectiveness of market changes and investment in grid scale and grid scale distributed sources of time-shifting devices. And to be able to develop, test, validate new modeling, simulation and analytical tools, as well as to evaluate different types of DER scenarios. And there are also efforts underway to develop a transactive energy type of framework to evolve both wholesale and retail markets to coordinate multi-actor, multi-objective, and multi-function investment decision-making. And I'd leave you with these takeaways. Given the directions in which we are going, while there's great controversy over how to approach this, there is agreement in the United States on the need for market reforms, because our market structures have been designed to date to support a legacy system. And this system is undergoing transformation. So similarly, the market needs to be reformed to support evolving a flexible, interactive, and innovative grid while still maintaining efficient, reliable, safe, and affordable delivery of electricity services. We need to reduce over time discriminatory qualification and performance requirements, restrictive market constructs, and implementation processes to promote revenue equality, and market opportunities for all resources, and to move towards more cost-reflective pricing to expose the value of resources, and to make flexibility available to network operators to manage a transforming grid. And very importantly, to promote transparency, assure material information dissemination, establish measures to avert market abuse, and provide other safeguards to enable end users and the small end users, commercial, residential, to make efficient market decisions regarding the usage of and investment in local devices, appliances, and technologies, and to be efficiently insured against risk. Thank you.